So today we're going to be looking at similar stuff with solving quadratic inequalities, but we're going to take a look at our calculator, use the tables and graphs on our calculator to help us see them also. And then we're going to work on some word problems that we'll look at also. So here they want us to use table and graphs to solve this inequality. X squared plus 8x plus 20 is greater than or equal to 5. So we're going to take our calculator and we're going to graph both parts. So y equals x squared plus 8x plus 20 and 5. And when we make our window for this graph, we want to make sure that we can see the max or the min, whichever this graph has. Does this have a max or a min? Okay, it has a min, opens up. Okay. X squared is positive. So when I graph it, I want to be able to see where the graph where the lines intersect well enough so I can find those 2 points. Now in this situation then, they want us to tell when x squared plus 8x plus 20 is greater than or equal to 5. So when I look at the graph here then, right, greater than or equal to 5 is which part of the graph of the parabola? Where's the parabola at in that case? Is it above that line at 5 or is it below the line? Okay, it's above the line because it says greater than or equal to. So our answer is going to be all the x values for where that is true. So if I look at the x values here, that it looks like the x value is, let's see, can't tell exactly where that is, but it's pretty close to here and pretty close to here, right? So since it says greater than or equal to, we're talking about all of these x values going this direction and all of them going that direction. The only thing is I need to find out what exactly those two values are, those x values are. But that's where it follows that the graph is greater than the line y equals 5. So let's look at the table too. Maybe that will help us to find those exact values. And if your numbers are way off like mine, if you go to second window, that's the table setup, and you can go back to 0 here. Now I know these numbers are in the negative, so I need to go approximately -3, -5. So go up here. All right, so we can see from this table that the x values at -3 and -5 show the y values at 5. So we know that those are the main x values we need to look at. So if we look at our table then, well, that's not what I wanted. If we look at the table, we can see that they're equal to 5 They're equal to 5 here and here. So which numbers show that y1, which is our graph on the left side, our parabola, which ones show where it's greater than y2, the line is 5? And we can see that y1 is greater here and here, which is the numbers that are less than negative 5 and greater than negative 3. Okay. They're equal to at negative 5 and negative 3, but from the table I can see that they're greater than negative 6, negative 7, negative 8, and so on, and also negative 2, negative 1, 0, and so on. So in this case, my answer is going to be that x is going to be less than or equal to negative 5, or x is greater than or equal to negative 3. The numbers that are smaller than negative 5 or the numbers greater than negative 3. So on my number line, since it says greater than or equal to, I have closed dots on negative 3 and negative 5, going to the left from negative 5, going to the right from negative 3. And then interval notation from negative infinity to negative 5, and that's a bracket at negative 5 because it includes it, or bracket negative 3 to positive infinity, parenthesis. So there we can also use tables and graphs to compare them. One of the things that I used to do is that when I was looking at these answers here, like in this question here, all right, so I marked the zeros on this at a negative 11 and 1, but that graph, does it open up or down? Okay, it opens up. So this graph, the graph here actually looks like this, all right? So if I drew a dotted line there to represent the graph, then I can see that the graph is above this line here, okay, when the values are less than negative 11, greater than 1. For number 10, if I drew the graph there, the graph would go through here like this, because it says negative 2x squared, so it would be a frown. So when is the graph greater above the line? Okay, it's above the line between those two zeros. Okay. So you could look at it either way, by solving it algebraically, or you could make graphs, do graphs and tables to do it also. Okay. Basically, whichever of those is easier for you to do is the way you should do them. In this case, we're looking at above the line. Letter B, they're using the same inequality basically, except they're saying, okay, so when is it less than 5? So if I take my picture here, when is it less than 5 then? It's less than 5 when it's below the line, okay? And it's below the line between those 2 points. So it's below the line here, so that'd be between them, so we would say that x is greater than negative 5, less than negative 3. and number line and interval notation to go with it. Because this is where the line y equals 5, okay, not the x-axis. So when it says to use algebra to do it, you want to factor if you can, or you could use the quadratic formula. When it says use a table and graph, then you can just graph the line, figure out where it's below or where it's above, whichever one you're looking for. So let's look at an application problem to go with these. The monthly profit of a small business that sells bicycle helmets can be modeled by this function, where x is the average selling price of a helmet. What range of selling prices will generate monthly profit of at least $6,000? So we want to know when this graph basically is above 6,000. Right. So we want to solve this inequality. So we're going to look at it graphically. We could try to we could get everything on the same side, try to factor if we wanted to, but the big numbers like this, we're just going to graph it. So on y1, and then put 6,000 in y2. Okay, so we need to make our window appropriate for this graph. So what's the first thing we need to change? Okay, our y max has got to be changed first of all. And what might be our y max then? Okay, so we need it to be larger than 6,000, right? So it could be 6,500. You could do 7,000. It kind of depends on where you want to go. Now here we're talking about the average selling price of a bicycle helmet, right? How much are bicycle helmets? $20, $8. Okay, so more than 10 possibly, right? Okay, so since X is the average selling price of the helmet, then we're probably going to need to change our X max. Do we care about the negative values for selling price? No, we don't. Okay. And X max, they might be 20, so let's try 20 for our X max. Okay, I'm just taking a guess of what it might be. All right, and I want to go a little bit bigger than that. So, all right, so let's graph it and see what we get here. All right. Okay, obviously the selling price is a little more than $20 then, right? Okay. So let's go a little bigger. Let's even increase it up to 50 and see what happens. Oh, that looks much better. Okay. We might even want to go a little bit farther, right? With both both our y max and our x max so we can see this a little bit better. Let's go back to our window. Let's go to 60 on the x, and let's go to 7,500 on the y. There we go. All right. Now, we want to know what range of selling prices are going to give a monthly profit of at least $6,000. So what do I need to find now? Okay, so we need to find both of these spots where these lines intersect so that we can figure out what the lowest prices are and the highest price is for getting $6,000 of profit. So second trace for our intersection points, number 5. All right, so our first curve was y1, second one's y2. And so here we get $26.04. That's our first intersection point. So then we find the second one. Second trace, number 5. First curve is a parabola again. Second curve is a line. Now for our guess, we have to scroll over to the other number. Get closer to it. We've at least got to get more than halfway to it. So, and then here we get $48.96. So my answer then is going to be average selling price of a helmet. What range of selling prices? Then when X is greater than or equal to $26.04 and less than or equal to $48.96. Okay. So anywhere in that range, they will make a profit of more than $6,000 in a month. So, but what we were trying, our main thing we were trying to do was find out where all of these values that are greater than 6,200, and not just one or two of them, all right, but all of them. So we have to write our answer then as an inequality, a compound inequality. You just can't say, well, greater than $26.04 and less than $48.96. Questions about that then?